Hey everyone, and welcome to this video where we will cover a powerful feature of the Robotiq Wrist Camera, the visual offset. This feature uses this tag and allows you to adapt a robot program just by looking at it. Are you ready to look into this? Let's get started. The visual offset is one of many features of the Robotiq Wrist Camera. When you receive your camera package, you will find enclosed these visual offset tags. The camera can be programmed to visually find the tag and use it as a reference for the position of its environment. This tag becomes a reference frame for certain parts of the cobot program. It is commonly used when moving a robot around different stations, like in a CNC machine tending application, for example. Also, it can add flexibility when a tray is placed at an in-feed and the exact position cannot be guaranteed. Like for a high-mix, low-volume production, when designing a dedicated jig is not justified. It is also useful when combining the cobot with an auto-guided vehicle, or AGV, as the point of reference to reorient in space. The visual offset can detect any translation in any axis, X, Y, and Z. It can also detect a full 360-degree rotation around the Z axis, as well as rotations around the X and Y axis. So before we start programming, let's look at some considerations. First of all, make sure that the robot can reach all the limit positions without entering in contact with its environment. Second, keep in mind that the precision is better near the tag. Like in our example, we put the tag in the middle of the tray to keep an optimum precision for all the parts. So the closest the product or the action is to the tag, the better precision you will get. Avoid positioning the camera exactly parallel with the tag, as this can create a direct reflection and blind the camera. This is especially true if the LEDs of the camera are on. You will see that there are visual indicators in the software to help you place the camera at the best distance and angle from the tag. If you work in a dark environment, increase the exposure before turning on the LEDs, if you can. The LEDs being turned on increase the chance of having a glare and make it a little bit harder to adjust. We also suggest using the manual focus to enhance processing time. Now let's look at the main steps to use the visual offset. First of all, you'll have to install and calibrate the camera, create a snapshot position as you normally would. And then you'll need to define a tag for the camera to recognize. And then you can program and use the find visual offset and apply visual offset features in the program. Now let's look at a real-life example that we will program together. So we are going to be emptying this tray. So the initial position will be taught to the cobot, and eventually when we run the program, we're gonna place it with different positions and orientations. So every time the camera will look for the tag here in the middle of the tray, and the positions of the movements to reach or to pick the parts will be offset, will be shifted according to the new position of the tag. So we are working with a camera that is installed, that is connected, and for which the calibration was performed for this work surface. If you're not sure how to install and calibrate the camera, please refer to the existing e-learning videos on our website. So the second step is then to define the tag so that the camera knows what to look for. So I'm still gonna go under installation, then UR caps, and in the camera menu, you will find the tag or tags section right here. So I'm gonna press the plus sign, the blue plus sign right here, and I'm just gonna keep the default name for now, tag 1. There you go, and then I'm gonna select the current calibration. This takes us to the tag definition menu. Now you'll notice that the title of this menu says far camera position. This is because it's done in 2 steps. The first one, the first picture is taken from afar to gain a wider field of view. And then we're gonna take a closer picture of the tag to have precision. So you'll notice that there are 2 menus here. One says distance and the other one says angle. So you want to have the two indicators in the green zones. If you have to move the distance and the angle, you can simply use this joystick at the right hand of the screen, and you can also use the align 60 degree to plane button. This will help you to have the best angle possible. So I'm gonna use a joystick. Now that the angle and distance are in the green zones, what I'm gonna do is I'm going to adjust the camera settings. So if you look at the lower left corner, this is where you can adjust the LEDs, the exposure, and the focus. So I'm gonna make sure that the LEDs stay off in this case because I got a good ambient lighting. And I'm gonna make the focus manual. Now I'm happy with what I'm seeing here. The tag is uniform. There's a good contrast between the black parts and the white parts. So I'm gonna go ahead and capture this. And then press next. So this takes us to the close camera position. So I'm simply gonna move the tag a bit closer, or the camera a bit closer to the tag. And I'm trying to have the tag as much as possible in the middle of the camera. So again, once the angle and the distance are between the green zones, I can go ahead and capture this. And then I'll simply press save and finish. So my tag was created. It's right here. It's shown as tag 1. So from that point on, I can go ahead and start a program, define visual offset and apply visual offset nodes are now usable. Now that we have our camera installed, it's calibrated, we have defined the tag in the installation menu, we can start programming. So we'll go ahead and use the program tree. So what we're gonna do is we're gonna be emptying this tray, as simple as that, and we're gonna put the blocks on that other side of the table. So the very first thing I want to do for this example is I'm just gonna create a move to take the robot to a home safe position. All right, so I'll just move here, and I'll be using active drive as it makes moving the robot around way easier. So I'll start from this position. It's above the work plane, it's not gonna hit anything. There we go. And then right ahead, I can start using the find visual offset node. I don't need to be moving the robot to the snapshot position or anything. It will automatically do so. So I'll go down the UR caps list and use the find visual offset node right here at the bottom. So you see it's yellow, it has to be configured. The very first thing I want to be doing is to select the right tag, right, or the tag I'm actually looking for. In our case, it's going to be easy because there's just one. There you go. And then you see here that it automatically creates a loop. So if the tag is found, it will automatically go down and execute the apply visual offset loop. So everything that is actually in here will be executed when the tag is found. So let's start, just to try it, let's start by just putting a pop-up in this loop. A pop-up that tells us that the tag was found. So now if I just go ahead and play, it will move to the further point first and then to the closer point. And if I go into the installation tab, so we see that the tag was found. So I can just press continue. And if I go to the installation tab, I can actually see what the camera is seeing. So this is a good insight as well. So far and closer, and there you go. Now that I know that my tag is being found by the camera, I can insert some actions right here. So instead of this pop-up, I'll just remove it. Then I can insert the moves that are going to be actually picking the parts. So those moves should be relative to the tag that you see right here. Okay, because we want to make sure that they follow whatever the position of the tag is. So it's very important that this move and then the next move are relative to the tag. So I'll go ahead and create an approach point. And a pick point. Now I'm going to use move L to go down to the pick point. Now that I have my approach point as well as the pick point, the next thing I want to do is to take care of the gripper, right? So if you remember, we should, as a good practice, activate it in a before start sequence. So I'll just add that before start and simply activate the gripper whenever the program starts. Activate, and I also want to make sure that we start the program with the gripper open. So I'll just go ahead and add a gripper open action right here. Alrighty. And then once the gripper has reached the pick point, I want it to close right on the part. I want it to pick the part. So again, I'll use that gripper close action. Now I want the gripper to take, or I want the robot to take that part away from the tray. So what I'll be doing is I'll simply be adding another move node, but I'll leave this one based on the position of the base rather than the visual offset. So then whatever the position of the tray is, it will always take this to the same place. So again, I'll go ahead and use active drive. So before we go too far in the program, let's give it a try first. So it's only gonna pick the first block and take it here. So let's give it a shot. Okay, now let's modify the program a little. I will teach these 3 positions in the apply visual offset part of the program to show you how to create a multiple pick sequence. Feel free to download the program attached to this lesson if you want to try it by yourself and if you want to see more details. All right, so if we look at the program now, what we have is a before start sequence that will activate and open the gripper. Then we're moving to a safe or home position. And then the find visual offset will be looking for the tag, and everything that happens in the apply visual offset will be executed if the tag was found. So we notice that the pick approach and pick points for the parts that are in the tray are all relative to the tag, right? And then for each part that I pick, I'm going to place it. I have this little folder that I've created, so I'm going to place it using the find surface, using the find surface node to be able to stack them without having to teach so many waypoints. All right, so let's try this program. So you will notice that it's not going to take a new picture for each part, right? Because all of the tray was programmed inside the apply visual offset node. Until all of them are executed. Now it's a bit of a brute force approach where I've taught each of them individually, but obviously, as I mentioned, feel free to use the palletizing template available in the UR caps or whatever other strategy that you might have in mind. So now I'll just go ahead and do the exact same thing by moving the tray to a new arbitrary position. And again, it starts at the same place, but you see that the closer or second picture is adjusted according to where the further picture was found. fine surface, open, gripper, and so on. So there we notice that it's very precise, that it's very easy to program, and that it adds flexibility. So now the tray can be anywhere near its original position, and it will be found accordingly. All right, so I hope that you appreciate this new visual offset feature and that you see how it can benefit your application. If you want more information, feel free to look at the user manuals. There's a lot of information on robotiq.com, and feel free to reach us at support@robotiq.com. Thank you very much. Have a great day.